Hello everyone, this is Mr. Regner, and this is our Chapter 5 practice test. You'll find this inside of the Big Ideas textbook on page 238. So when you go to page 238, you'll see this exact same page. And my goal today in this recording is basically to go through the work here in the practice test to show you kind of step by step how I would answer the questions. That way you can use this for a couple of reasons. Number one, you can use it as an answer key to check your work. Number two, if you get stumped on a question, you can use it to watch how I would solve the problem, and hopefully that may help you out as well. I don't know if this video is going to be best served by you watching the whole thing from beginning to end, or if it would be best for you to skip ahead to the problems that you need. Either way, use the video however you'd like to prepare for the Chapter 5 test. So I'm on, again, page 238. So go there in your books and kind of follow along with me. Let's go ahead and get started with number one. Now, number one says identify the terms, coefficients, and constants of q over 3 plus 6 plus 9q. So if I'm identifying terms, I can think of these plus signs as being the separators of my terms. So put a little line there, and I have three terms. Q divided by 3, or q thirds, 6, and 9q. Those are my terms. Coefficients, those are going to be the numbers in front of variables, or the numbers that are paired with variables. So my coefficients, sorry I'm trying to get all multicolored on you here. Obviously I have 9 in front of the q, but then I have this invisible 1, there it is, in front of the other q. That coefficient is also important. So I have 9 and 1 as my coefficients. And then finally it says the constants. To identify the constants, well, that's an easy one. And I have a green pen here to identify my constants. I have 6. 6 is a constant. Now you may be looking at this and say, well, wait a minute, what about that 3? Isn't 3 a constant? Well, actually, a constant is just a term that has no variable part. In this case, the 3 is there in the same term as 1q divided by 3. That means that that 3 is not a constant in this particular expression. Let's move on. Take a look at number 2. It says evaluate 4b minus a when a equals 12 and b equals 7. All right, so this is a situation where I just substitute, solve, and answer. So I'm going to take out that a and put in a 12. Take out my b and put in a 7. So I have 4 times 7 minus 12. Well, that's no problem. Now we're just doing order of operations. Think PEMDAS. Whenever you think order of operations, I'm going to multiply first. 4 times 7 is 28. And then I can subtract. 28 minus 12 leaves me with 16. So my answer for number 2 is 16. Moving on to number 3. Number 3 says, write the phrase as an expression. So I need to read it here and then write it down. So 25 more than 50. Well, that would be 25 plus 50, or 50 plus 25. Either way works because, again, that commutative property of addition says I can switch them around. Okay. Moving on to number 4. It says 6 less than the quotient of 32 and a number y. What? I've got to take some time on this one and think about it. 6 less than. That means I'm going to subtract 6. But it's subtracted from the quotient of 32 and y. That means I need to take 32 divided by y. That's the quotient of 32 and y. And then 6 less than that, so minus 6. I organized this, by the way, by putting 32 divided by y into parentheses, just to kind of group that together in my own head. Technically, I wouldn't really need those parentheses because order of operations, again, PEMDAS, says that I would divide before subtracting. So if you didn't have the parentheses, you'd still be okay. Let me move on and take a look at number 5. Number 5 says, simplify the expression and explain each step. I really hope I've given myself enough room. I think I have. So let's see here. We have 3 and 1/10 plus, and then in parentheses, 8 and 6/10 plus m. Now for this one, I'm going to kind of explain this as best I can and maybe show some of the steps, but you want to follow along, obviously, very, very closely to what I'm saying as well. So we have 8 and 6/10 plus m. I can't do anything with that. The m is unknown. I can't add that with m. However, I can move my parentheses over. So now I have 3 and 1/10 plus 8 and 6/10 plus m. Well, now we're talking. Now we're in business because I can add these two numbers together. They are decimals, so we just line up our decimals and add. When I do that, I end up with, let's see, that'd be 6 plus 1 is 7, decimal down here. 8 plus 3 is 11 plus m. So 11 and 7/10 plus m. By the way, when I switch my parentheses, that's what we call the associative property. And it's the associative property of addition because we're adding. Moving on, let's take a look at number 6. Number 6 says 2/3 times t times 1.5. Lots going on here. Now again, we've got that t in the middle. I don't like that. So I'm going to use the commutative property to switch the order of my multiplication. That's the commutative property. Says I can switch the order when I'm multiplying. Well, I still don't like it though. I can't multiply t times 2/3. But now I can use that associative property. You can't read that probably, but it says associative. I'm going to take t times, and now 2/3 times 1.5. All right, now we're in business because now I can handle this. I can multiply these, the fraction and the mixed number, together, and then keep the t separate. So I'm going to have the t times the answer to this problem. Only catch is here, I don't know the answer to that problem. I'm going to have to work that out. So I'm going to have 2/3 times 1.5. I'm going to turn that into a mixed number. Or I'm sorry, the mixed number into an improper fraction. 2 times 1 is 2, plus 1 is 3. Keep the denominator the same. That's 3/2. Now I multiply straight across. 2 times 3 is 6, and 3 times 2 is 6. That's 6/6. So that would be 1, right? Well, now look at this. T times 1. I can use the multiplication property of 1, and that says that t times 1 equals t. So no matter what t equals, could be 10, could be a billion, could be a half, whatever it is, times 1 equals the same thing. Move on to number 7. Number 7 says 4 times the sum of x plus 8. Well, this is set up with that old distributive property. Right, we know we can distribute that 4 across the parentheses. So 4 times x is 4x. Keep the sign the same, plus. And then 4 times 8, that's going to be 32. That's as simplified as I can get, 4x plus 32. Here's number 8. Number 8 says 4t plus 7 plus 2t minus 2. All right, now here we have a situation where we have some like terms. Remember, the term 4t and 2t have an identical variable part, the t's. And then we have 7 and 2. These are what we call constants. So I can use that commutative property and switch these around. 4t plus 2t plus 7 minus 2, right? That's the commutative property of addition because I switched the order around. Now I can combine my like terms. 4t plus 2t is 6t. Remember, you just add their coefficients together and the t goes along for the ride. And then over here I have 7 minus 2, which is 5. So my simplified expression is 6t plus 5. Let's move on and take a look at number 9. Number 9 says, factor the expression using greatest common factor. All right, no problem. So 18 plus 24. This is what we worked on in chapter 5.5. So I want to look at my two numbers here, 18 and 24, and I want to think about the greatest common factor, a number that goes into 18 and 24. Now in my head, I immediately think of the number 6, because 6 times 3 is 18 and 6 times 4 is 24. If you're not getting that or not catching that, You could make factor trees, you could make a factor rainbow, find all the factors for 18 and 24, and you would settle on 6 as the greatest of all the common factors. So with that being said, I can think of this 18 as being 6 times 3. And then 24 is 6 times 4. With that being said, I can pull out that 6, that's the common number between them, and then inside the parentheses, I'm going to use whatever's left. That's the 3 plus the 4. There you go, that's factored. The factored expression is 6 times the sum of 3 plus 4. Let's try out number 10. Number 10 is 15x plus 20. All right, so I'm looking at 15 and 20, and immediately I see 5. That's the common factor. It's the greatest common factor. Goes into 15 and 20. Again, notice 15x. I'm not worried about the x, just thinking about the 15. So I'm going to pull out that 5. That means that 5 times 3x is 15x. And then 5 times 4 is 20. Pull that 5 out, put it on the outside of the parentheses, and whatever is on the inside is what's left, 3x plus 4. 5 times the sum of 3x plus 4 is the factored expression. Take a look at number 11. This one says 32x minus 40y. Don't be scared of the two variables. We can just think of the coefficients here. 32 and 40. Well, let me think here. 4 times 8 is 32, and 5 times 8 is 40. So 8 is my greatest common factor. Again, I'm finding that pretty quickly. I realize that. But you can always take the time to make your list of factors if needed. Notice that my x and my y just get attached here onto those other factors. 8 times 4 is 32. 8 times 4x is 32x. Pull out that common 8 that's on the outside of my parentheses, and whatever is on the inside is what's left. 8 times the difference of 4x minus 5y. That's number 11. Let's move on into our word problems. Now these potentially could be some of our tougher questions, only because we have to read them and understand them. So number 12, it says playing time is added at the end of a soccer game to make up for stoppages. An expression for the length in minutes of a 90-minute soccer game with X minutes of stoppage time is 90 plus X. I'm going to write that down. 90 plus X. In other words, it's 90 minutes of soccer plus the amount of time that the game was stopped. How long is a game with 4 minutes of stoppage time? In other words, we're going to think that X equals 4. Well, this is just a substitute, solve, and answer problem. Right? Substitute the 4 for the X, solve it. That means that that game is 94, and I guess I could even say 94 minutes. Let's move on to number 13. It says the expression 15 times X times 6 represents the volume of a rectangular prism with a length of 15, a width of X, and a height of 6. Simplify the expression. Well, I don't mind if I do. So for this one, we can use that commutative property. Switch these order or switch those order. Doesn't really matter. I'm going to switch the the X and the 6. Right? Just kind of do the old switcheroony here. Right? That's that commutative property. Okay, now I have 15 times 6, and I have X. Well, 15 times 6, I've got to think about this for a second. I can do 15, 30, 45, 60, right? If we think about that, 15 times 6 we might know is 90. If we need to work that out on the side, we certainly can. No big deal there. We end up with 90 times X, or I could even just say 90X. Make it nice and simple. Let's move on to number 14. Number 14 says, the Coiling Dragon Cliff Skywalk. What? That's weird. The Coiling Dragon Cliff Skywalk in China is 128 feet longer than the length X in feet of the Tiananmen Skywalk in China. I might have to read this multiple times to figure it out. The world's longest glass bottom bridge, located in China's Zhangje National Park, is about 4 3/10 times longer than the coiling dragon's cliff skywalk. Write and simplify an expression that represents the length in feet of the world's longest glass-bottom bridge. All right. Woo! Lots going on there. I'm realizing, too, in my video, I'm not sure you can actually see that at all. Hopefully you can. It looks kind of fuzzy on my screen. You can always look in your book on page 238. This is one where they're giving us a bunch of information, and we need to piece it all together. So I'm going to go ahead and say this is the coiling dragon skywalk. Okay, we know that it is 128 feet longer than x, than the length x of the Tiananmen skywalk in China. So the Tiananmen skywalk, hold on, yep, we'll call it the Tiananmen skywalk is x. The coiling dragon cliff skywalk, CD skywalk, is 128 feet longer than x, right? So it's 128 plus x. And then it says the world's longest glass bottom bridge is about 4 3/10 times longer. Hold on, that one is called the Zhangjiang. I'm probably mispronouncing that, but I'm going to call it the Z. And it says it's 4.3 times longer than the coiling dragon. So here's the coiling dragon, 128 plus x. It's 4 3/10 times longer. Write and simplify an expression that represents the length in feet of the world's longest glass bottom bridge. That's this one. We're trying to figure out the length of the Zhangjiang National Park Bridge. So here's our expression. Again, I'll rewrite it. Hopefully you're looking at that and you're thinking, okay, wait, that looks like one I could simplify by distributing. Distribute at 4 3/10 times 128 and times x. So I don't know this one. I'm going to do this off the side here. 128 times 4 3/10. Remember, when you multiply with decimals, we can ignore the decimal to start. So 3 times 8 is 24. 3 times 2 is 6, plus 2 is 8. 3 times 1 is 3. Add my placeholder 0. 4 times 8 is 32. 4 times 2 is 8, plus 3 is 11. And 4 times 1 is 4, plus 1 is 5. Add them together. 4 plus 0 is 4. 8 plus 2 is 10. 3 plus 1 is 4, plus 1 is 5. And 5 plus 0 is 0. Now add that one place value over for the decimal. We end up with 550 and 4/10. We can't forget about the other part. 4 3/10 times x is just 4 3/10 x. So this is my simplified expression to represent the length of the longest glass bottom bridge in the world. How about that? I think for number 14, as I look at this, I really think that this part could be confusing, all the weird names, because we may not be familiar with those names. So find a way to abbreviate, as I did here, to make that simpler for me to understand, and then it's just a matter of kind of comparing the ones that we figured out here. Let's move on. Look at number 15. It says a youth group is making and selling sandwiches to raise money. The cost to make each sandwich is $8. So I'm going to write that down as a little note for myself. $8 for the cost of one sandwich. Good to know. And then it says the group sells 150 sandwiches for a total of 150 each plus $450. That makes sense to me. 150 times the cost of one sandwich. Then it says plus $450 or 450. How much profit does the group earn for each sandwich sold? So we're really looking at this profit, right? That's where that extra $450 comes in. So in order to answer this question, I want to figure out what each individual sandwich would have added onto it. That's the profit we're looking for. So I know there's $450 profit for 150 sandwiches. How much profit for just one sandwich? And I can figure that out by simply factoring this expression. So I want to look at 150 and 450 and try to find the greatest common factor. I'm thinking it's got to be 50, right? 50 goes into 150 3 times. 50 goes into 450. We can pull that out, right? So hopefully you found that factor pretty easily. I realize, again, as I did this, I did it super quickly. But hopefully if you need to take some time to write down those factors, you certainly can. All right, so I have, wait a second. You know what, as I look at this again, 1 second here, let me think about this. Okay, I think I figured something out. I wanted to go with 50. That was my gut instinct, and I was so sure of it. But I started thinking about it, like 150 divided by 50 is 3, and 450 divided by 50 would be 9. And since 3 and 9 have common factors of 3, that actually is not necessarily true. That's not the greatest common factor. I should have known, right? Actually, 150 goes into 450. Check it out. 150 times 3. 3 times 0 is 3. 3 times 5 is 15. And 3 times 1 is 3. Plus 1 is 4. That's 450. So actually, my greatest common factor is 150. I can think of this as 150 times h. I can think of this as 150 times 3. I pull out the 150, and I have just h plus 3. Now, that's great that we factored that expression. But now to think of what that means for each h, for each sandwich, I'm adding on $3. So that means there's a $3 profit for each sandwich. That one almost got me there. $3 profit for each sandwich. Got to think about that greatest common factor. One more question left. It's number 16. Here we go. It says you make party favors. Let's see if you can see that. You make party favors for an event. You tie 9 inches of ribbon around each party favor. This is number 16. There's 9 inches around each favor. All right, write an expression for the number of inches of ribbon needed for n party favors. Okay, let's stop there. So the expression is going to be, if there's n favors, and I have 9 inches for each n, let's say n is 2. That means I have 9 and 9. Let's say n is 3. I have 9, 9, and 9. That means I'm multiplying 9 times n. Right? That would be the amount of ribbon I would need for n party favors. 9 times n. It says now the ribbon costs $3 for each yard. Write an expression for the total cost in dollars of the ribbon. All right, so if it's 9 inches, I want to convert the 9 inches to yards, right? The ribbon costs $3 for each yard. If I have 9 inches, I need to think about how many yards that would be, or how much ribbon I would have. I have 9 inches, and I want to go for a yard. So think about it this way. Maybe I'll do a visual here. Okay. There's 9 inches. Now 1 yard, we probably know is 3 feet, right? 3 feet in the yard, we memorized that earlier in the year. But we also know we can convert that because there's 12 inches in 1 foot. So if there's 12 inches in 1 foot and we have 3 inches, think 12 times 3 to get 36 inches. So how many 9-inch segments would there be in 36 inches? We can do this a couple of ways. We could just try multiplying 9 and see if we get to 36. We could take 36 and divide by 9. Either way, we're going to figure out how many groups of 9 we would need. I'm going to go with division here. 36 divided by 9. If we take 36 and divide by 9, we end up with 4. 36 divided by 9 is 4. I'm going to try to draw this out here as I can. Kind of complete my visual. Right, there's 4 9-inch parts that make up 1 yard. So I have to think about this. If I have 9 inches times the number of favors, that means I have to have 4 different favors to equal 1 yard. So 4 favors make up 1 yard. That means I'm going to take my 9 inches and cut that into 4. So think 1/4 times n. That's going to be the amount, 1/4 times n, of 1 yard. Again, if it costs $3 for each yard, I can multiply that times 3. So I have $3 times 1 yard. And again, each individual part here is 9 inches. 1/4 of that is 9 inches. So 1/4 times n would be 1 yard. And then $3 per yard. That last one, I'd say, is probably our trickiest one. We've got to do a lot of converting there, kind of mentally taxing to think that one through, but hopefully that makes sense for you. As you look at page 238, a lot of these questions are very, very similar to the types of questions you're going to see on your chapter test. So this really, truly is the best way to practice and prepare. We'll talk more about this in class. If you have questions, please write them down so you don't forget them, and then you can ask me, or you're always welcome to email me as well. Thank you very much.